let's do some chain rule guided practice. We're just taking the derivative, using the chain rule, and what other rules they throw at us. Whoop, I don't know why it switched to that. F prime of x. What's the outermost function? It's x to the negative 2. Leave this entire inside the same. Don't change anything. Now take the derivative. Next up, all right, that's the answer, right? Just one step, right? Next up. Now, first off, remember, last one, probably best to write this as 2x squared minus 1 to the negative 1/2. So over here, so f prime of x is going to equal negative 1/2 times all this stuff to the negative 3/2 times the derivative of the inside. And if we want to clean that up a little bit, which again we should, we see that that's going to be negative 2x on the top divided by, and then you could say this is, well, however you want to do it. I guess we'll just have the square root of 2x squared minus 1 cubed. Okay. Oof, number 3. A couple of chain rules within a product rule. No thanks. But I suppose it's still better than multiplying all this out, right? Because, come on, who wants to do that? So notice that we've got a product. 2 parts, right? Each of which is going to require a chain rule, right? But that's okay. We can do that. So this is going to be 2x plus 1 times the derivative of the inside, which is just 1. So whatever. Times, okay, I guess we keep this the same. And now, keep the first the same times the derivative of the second part. What are we multiplying by? Yep, that's right, it's 2x. Okay, and just to highlight what we were doing, there's your second part there, second part there, second part there, second part there, right? You can go ahead and clean that up if you want. I will pass. Well, the only thing worse than a chain rule within a product rule is a quotient rule within a chain rule. It's okay. We can do anything if we try. What's the outermost function? That's right. It's x to the 2/5, right? So take the derivative of that. Leave the inside the same. Okay? Leave that inside the same. Let me just write that a little nicer. There you go. Okay, now, a little bit of a painful part. We have to multiply by the derivative of the inside. Now, we can just use parentheses for this, right? It's going to be low d high minus high d low all over low squared. There you go. I'll bring that a little lower down. All right. Have all that space. All right. Ooh, well, that's not going to be fun either. But one thing that might be nicer would be if we wrote it like this. All right, so at this point, we have 1/2 times the inside to the negative 1/2, and leave the inside the same, times the derivative of the inside, which again, it's a quotient rule, but not super terrible. Right, low d high minus high d low all over low squared. we could simplify that top a little bit. Yeah, let's do it. We've got some time, right? This is, well, you know what? I really don't want to. So, if you were to put this back in radical form, which you can, it would look like this. Not the loveliest thing in the world. Right? Not what anyone wants to see. But anyway, you get that. Now, what's this? I guess we're going to have a quotient on top. Maybe I'll just say times. I don't want to put it on top, really. I'll just kind of, you know, multiply it. So we're on even footing. And we're going to get, well, let's see. This up here is going to be 16x squared plus 12x minus 8x squared plus 4. So I guess that's going to give us 8x squared plus 12x plus 4 all over 4x plus 3 quantity squared. And if we wanted to simplify that a little bit more, because why not, we could say, hey, look, these are going to cancel with the 2. This will be a 4, 6, 2. And I'm going to have a final answer of, looks like 4x squared plus 6x plus 2 all over square root of 2x squared minus 1 over 4x plus 3, and then times 4x plus 3 quantity squared. Whew.